Okay, we have already done with the Schrodinger's time dependent equation. So let us quick recap of Schrodinger's time dependent equation. In a short form I am writing Schrodinger's time dependent equation. Good. What is that? I h bar dou psi by dou t, where psi is a function of x and t, is equal to minus h bar square by 2 m dou 2 psi by dou x2 by v of x psi. Yes. So this is a one dimensional version in Cartesian coordinate. Of course we can generalize into 3 dimension. So in 3D Cartesian coordinate it will be I h bar dou psi by dou t minus h bar square by 2 m Laplacian of psi x y comma z t plus v, then it will be a 3 dimensional potential, and psi as a function of x y z t. And so many times we have discussed earlier what is the Laplacian operator, where the Laplacian is nothing but the operator is dou 2 by dou x2 dou 2 by dou y2 plus dou 2 by dou z2. Yes, good. Now we will discuss the Schrodinger's time independent equation. Schrodinger's time independent equation. Time independent equation. Our technique, what we are going to follow, is as follows. I mean, we will write this capital psi into the small psi, and of course we will write it in let's say phi. I'll take phi of t. What is the meaning of that? The meaning of this is I am assuming the solution, what is psi x comma t, is separable. Separable means in space and time. In which format? In a product format, where the space variable, there is a function of the small psi. So small psi is a function of x and small phi is a function of t, time. So in this format I have taken it, and this technique is called separation of variable. In this case, which variables we have separated? We have separated the space variable and the time variable in this particular format. I am assuming it. We can take it in this format. Okay. So what is the equation, governing equation? Again, I will go for the one dimensional equation. I h bar dou psi by dou t is equal to minus h bar square by 2m dou 2 psi by dou x2 plus v of x psi. This is the solution in 1D, and in 1D we are doing it. So let us try to do the differentiation. Dou psi by dou t, it will be what? So it will be d phi by dt. Carefully observe the difference. Here it is a partial derivative, here it is a total derivative, because small phi is a function of t only, so there is no meaning of partial derivative here. Similarly, you can see if I do the space derivative with respect to x, this is nothing but d psi by dx, keeping phi as constant, and from here if I do the double derivative also, the it will be nothing but d2 psi by dx2 into phi. These are the two key things we are going to use, and we are going to plug it in the previous equation. So let us plug it in. What happens if I plug it in? So what are the things I am going to plug it in? I am going to plug it in this result, and I am going to this result into this equation. So let us try to do it. If I try to do it, it will first will be I h bar. So instead of dou psi by dou t, it will be small psi of x into d phi by dt. I am not writing phi as a function of t. I don't have a place to write almost because it's covered, because it will be lengthy equation. Dou 2 psi by dou x2, it will be d2 psi by dx2 into phi of t plus v of x. Psi is nothing but, capital psi is nothing but small psi into small phi. Good. Now in the next step, what we are going to do, we are going to divide it by capital psi. So if I am going to divide it by capital psi, what will happen? 1 by phi t d phi by dt, it will be coming minus, it will be coming 1 by psi x d2 psi by dx2 plus v of x. Now carefully observe, the right hand side is entirely a function of x, whereas if I talk about the left hand side, this is entirely a function of t, and that is why it is called variable separation. In here I have given you the meaning, but the proper meaning you will give it, you will get it from here. So it is a very common technique while solving the partial differential equation. So right hand side now becomes entirely a function of x, left hand side is entirely a function of t. Now what is the meaning of it? The meaning, it tells you that it can be solvable only if both of these things are equal to some constant, and I am going to take that constant as capital E, and you will see that the constant I will take it as, it will have the same meaning later. So I am taking it as the constant E. Let me go to the next page. Then, so what is there initially? I. So what is there in the last one? This is I h bar. I will take this one is equal to E, and this is independent equal to E. Okay, I h bar, I h bar 1 by phi d phi by dt is equal to E, and another thing is what? Minus h bar square by 2m 1 by psi d2 psi by dx2 plus v of x, that should be equal to E, minus h bar square by 2m 1 by psi, small psi, you can see I am clearly writing small psi, v of x is equal to E. Let us see the equation number 2 in the beginning. We will come to equation number 1 little bit later. I am going to recast this equation. Sorry, d2 psi by dx2 1 by psi. I will put it minus 2m by h bar square v of x is equal to minus 2m by h bar square E. I am putting the E on the left hand side so that I can write it like this: 2m by h bar square E minus v of x is equal to 0, or in the final form I can write it d2x by dx2 plus 2m by h bar square E minus v of x psi is equal to 0. and this is the celebrated Schrodinger's time independent form in Cartesian coordinate one dimension. So 1D Cartesian coordinate representation of Schrodinger's time independent equation. Now we will come back to equation number 1. From equation number 1, what is the equation number 1? Have a careful look. I h bar 1 by phi, I h bar 1 by phi d phi by dt is equal to E, and you can very much solve it from your knowledge of plus 2 level ordinary differential equation. So d phi by phi is equal to E by I h dt. You can integrate it and you can get it exactly the format of phi. Can you tell me what is it? It is quite easy. So phi as a function of t is nothing but e to the power minus I e t by h bar. And exactly that is the relation. In the beginning, if you remember, I told there is a relation between the capital psi and the small psi, and that is nothing but you are getting it from here. And still, if you remember, I have taken capital E as a constant. Now you can give a meaning to the constant, a physical meaning to the constant. If you see the dimension of the T and dimension of the reduced Planck constant, capital E should be energy, and exactly that is the energy. So in later class we will talk about more of this equation, and the main goal for this course will be we have to solve this Schrodinger's time independent equation for different quantum systems. Thank you.